Section 4.4. All right. In this, we're supposed to simplify to a single logarithm. Well, this is already a single logarithm other than the minus on the outside. And the minus is like a -1, so it can go up as the power. And a negative power means puts the 1 into the denominator and the 7 into the numerator. And so this becomes log base 3 of 7. So the -1 goes up and takes the reciprocal of the 1/7, or puts 1/7 in the denominator, which is the same as taking the reciprocal. All right, number 6. Both base 4, when you add, that's what you get from the log of a product. So this is log base 4 of 3 times 7, which is 21. So you could just write 21 there. And that would be a single log base 4 of 21. Of 9, when you add, you multiply. So this would become the log, and this is in base 10 because there's no 10 put there, no number, of these two multiplied. So 2 times 3 is 6. X to the 4th times x to the 5th is x to the 9th. Here we're subtracting. It's log base 10 again. But it's when you subtract, you divide. So you got 12x to the 4th divided by 4x. And so x would cancel one of the x's, and 4 goes into 12, and it becomes log of 12 divided by 4, 3, and x to the 4th divided by x, x cubed. Single log. And this one, this is the more complicated one here. We got a number in front which would go up as a power. And you can use the negative and take it up, or just do it without taking the negative up. It'll end up the same. I'm going to put the half as the power of the y. So we have the log of x minus the log of y to the 1/2 power is the square root of y, plus, and the 3 will go up as the power of the z, and so it becomes log of z cubed. And then, to go to a single log, when you subtract, you divide, so we're going to have the log x divided by the square root of y, and then this is plus, so times z to the 3rd. And now this kind of gives you a hint on what we're supposed to do down here. We're supposed to take it apart and go to a whole bunch of it, expand it using the properties. So we have a log, and it's going to be the log of the a squared plus, because these are times, the log of b to the 3rd, and this is divide, so that would be minus the log of c to the 5th, and these powers can come down in front of these, so it becomes 2 log a plus 3 log b minus 5 log c. 21. The square root is basically a 1/2 power. So the half can come down, and it would be 1/2 the log of, now I'll just do it all at once here. So we'd have the log of the 1/2 takes care of the square root. We'd have the log of x to the 3rd, and times, so it becomes add the log of y to the -4, and then I can bring down the power, so I'll have 1/2 times 3 log x minus, because the minus 4 comes down, minus 4 log y. Now this one, the square root's not on everything, so first we're going to have to split it. So it's going to be ln of the x, and it's divided by this, so it's minus ln of the square root, which I'm going to write as a power, of 1 minus x squared. And then I can move the power down there, so I'll have ln x minus 1/2 ln of 1 minus x squared. And I can't split this up. This is log of the sum or difference, so there's nothing I can do on that. It has to be the log of a product, which I can split into sums, or log of a quotient, division, that splits to subtraction, but not the log of two things subtracted. That stays like it is. Okay, 27, this is the kind that we did spend time talking about. So I'm going to go down here and write that one. That one is, let me get it up here so you can see it while I write it down. 4 to the 4x minus 7 equals 3 to the 9x minus 6. So I wrote it down here. And what we want to do is to get a common base. And so we can do it in base E, base 10, whatever. E's easy to write. E to the ln 4, that's another name for 4, to the 4x minus 7 equals E to the ln 3, that's another name for 3, to the 9x minus 6. So then we take and multiply the powers, because it's something to a power, you multiply the powers. So we have ln 4 times 4x minus 7 times ln 4 equals, that's what this all would simplify to. And this would expand to be 9x ln 3 minus 6 ln 3. There's an x in this and an x in this, so I'm going to subtract this one from this one. And I'll do this not like I did in class. I had you guys just go straight to decimals, but I'm just going to write this as 9x ln 3 minus 4x ln 4 by subtracting 4x ln 4 from both sides. And now I've got my x's on this side, so I want to put this onto this side. So I'm going to add 6 ln 3 to both sides. And so I'm going to have minus 7 ln 4 plus 6 ln 3. Now I'm going to go to my calculator, wherever I put it. And now enter some numbers here. So I've got negative 7 ln 4, close parenthesis, plus 6 ln 3, close parenthesis. And this side comes out to be negative 3.1123324, rounded, equals, there's x in both of these, so I can pull out the x, and then it would be 9 ln 3 minus 4 ln 4. 9 ln 3, close parenthesis, minus 4 ln 4. So I get 4.3423 x, so I've just got to divide this by 4.3423. And I find that x is equal to that whole thing divided by, oh, I better put parentheses around it. This is my answer for this side, the 3 point whatever, divided by my answer there, and I get x has to be 0.71675. Now I'm going to check my answer. I'm going to store this. I'm going to go to store and into x, my answer here. And if I've done this correctly, I should be able to type this side in, 4 to the power 4x minus 7, and I get this number. It's really small. It's times 10 to the minus 6. And I should be able to do the same thing on this side, 3 to the 9x minus 6, and I should get the same number. And I do. So, storing the answer for x in x then allows me to just type both sides of the equation and check to make sure it works. All right, 30. So I'm going to write that down. I'll just get another piece of paper here so I don't have to write it all down. There's 30. So I got to work it out. So I'm just going to write it. I'll do this in base e. So 20 is e to the ln 20. 1.07 is e to the ln 1.07, and that's to the x. This was not to anything, so it's just that. Equals 8 is e to the ln 8 times e to the ln of 1.13, and that is to the x. And so the x comes down times this, and when we're multiplying we add, so we have x ln 1.07 plus ln 20, that's the power of e on this side, equals e to the x times ln 1.13 plus ln 8. Add this to these multiplied. So the e's become unimportant. We now just set these two equal. So I got to get all the ln's on one side, x's on one side. So I'll just subtract these from this side. So I'm just going to do, and there's x times both of them, so I'm just going to do ln of 1.07 minus ln of 1.13, and I get negative 0.0536x equals, and I'll subtract ln 20 from both sides, so I'll have ln 8 minus ln 20, and that's 1.61029 whatever, and then I've got to take that and divide it by that previous answer. So this divided by, and I'll just type it in again, parenthesis ln of 1.07 close parenthesis. Oh, I didn't put close parenthesis on this last time. That messes it up. And I didn't do it there. I messed up both of them. So these are not the correct numbers. I didn't close my parentheses. I hope you don't do that. Clear, let's start this again. So I want to do ln of 1.07 close parenthesis minus ln of 1.13 close parenthesis. So this side should have been negative 0.054559, whatever. X equals, now on this side I've got to subtract from natural log of 8, I need to subtract ln 20. So it's ln of 8 minus ln 20, and I'm remembering to close my parentheses now, and I get that number, negative 0.91629. So I got to take that divided by that previous answer to get my x. So that divided by my previous answer, which was parentheses, ln of 1.07 close parentheses minus ln of 1.13 close parenthesis, enter. So x should be 16.7944. I can store that in x, and then I could type in my original problem, 20 parenthesis 1.07 to the x. That's the left side. Now let's type in the right side. 8 parenthesis 1.13 close parenthesis 2x. And if I've done it correct, they should come out to be the same. And they do. Okay, so that's how we do these problems. So 33. Oh, there's a little bit different here now. So we have a log expression and we want to solve it. So we're going to change it to the power expression. So that was the first thing we gave you, and that was 2 to the 3 equals this. 2 to the third is supposed to equal 7x plus 8. Well, 2 to the third, 7x plus 6, thinking ahead. 2 to the third is 8, so I have 7x plus 6 equals 8. Subtract 6, and we get 2 equals 7x, divide by 7, and x equals 2 sevenths. That's 33. 36. Let's get everything over on the other side. So we get, subtract 5 from both sides, and we get 4 ln 5x equals, subtract 5 from 2, it's minus 3. Divide by 4, ln of 5x equals negative 3/4, or negative 0.75. And so this is in base e, so I've got to take e to the negative 3/4, changing it to the power. E to this power equals 5x, and then I divide by 5, and I get x is equal to e to the negative 3/4 divided by 5. And I can work that out. Let's find out what that is. E to the negative 0.75 divided by 5. That's my answer for x, so I'm going to go down here and store it in x. And then I'm going to type this equation in and make sure I did this correctly. So it's 4 ln of 5x, close parenthesis, plus 5 is supposed to come out to equal 2. And it comes out to equal 2. So I've done it correctly. 39. So we need to do, this is a sum of logs, so we multiply, so we get log of x times x plus 3 equals 3. This is in base 10, so I'll now change this to a power equation. 10 to the third equals this. And this is x squared plus 3x equals 10 to the third, or 1,000. So x squared plus 3x minus 1,000 equals 0. And I'll use my quadratic formula in my calculator. My A is 1, my B is 3, and my C is negative 1,000. And I get two possible answers, 30.158 something and negative 33.158 something. And now logs can't be of negative numbers, so the negative one is an extraneous answer, doesn't work, and this is the only answer that will work. And I can put that into x and type that out, and it'll show that they are equal. 42. 42, we got subtraction, so that means divide. Log base of x plus 5 over x plus 2 equals 2. So going to a power equation, 10 to the 2, 10 squared is 100, equals x plus 5 over x plus 2. Multiply both sides by x plus 2 to get that out of there. So I have 100x plus 200 equals x plus 5. Subtract x from both sides. Subtract 200 from both sides. And divide by 99. And that's a negative number. How big is that? That's not quite negative 2. So I think it would work, because this is smaller. Let's find out here for sure. Negative 195 divided by 99. And that's not enough negative to cause this to be a log of a negative number, so this should work. I'll store it in x, and I'll check. I'm going to type in log of x plus 5 minus log of x plus 2, and it's supposed to come out to be 2, and it does. So that's the correct answer. And that's all that I asked you to do. Okay.